Hello, everyone. Today is May 9th, 2025. We actually have the PDF file for the 2025 AP Computer Science A's FRQ questions. So I'm going to work on these problems and give you the answer. So right now, let's look at the problem one. So problem one, this question involves workers who are paid through a dog walking company to take a dog for 1 hour walk. So every dog you take it, you will walk for 1 hour. And then the company has many dogs that need to be walked during each hour of the day. So there is a dog walking company, and this dog walking company, let's see, this dog walking company has the available dogs for a certain hour. So return the number of dogs always greater than 0 that are available for walk during the time specified by 20 hours. So you give them, say, hour 22, they will give you the number of dogs that you can walk. And then there's a number of dog walk basically for a certain hour, and then it actually decrease by the number of dog walks. So here you update your dogs. So by the hour and number of dog being walked, then you will actually update the number of the dog available. And so basically this one looks like you need to have a table to store each hour how many dog available. And then when certain dog being updated, they will be changed. And then this is update dog. Okay, so there's a available number of dog available, and also update dog to update which dog will be available at certain hour. Then dog walker would have the maximum number of dog that can be used. And then there will be a dog company associated with that. That is the company that the dog walker is associated with. And then you have a contractor to assign the maximum dog and the company that is associated with. And then you walk the dog from the company. So here you have one function that's a part A, you need to do walk dog. So you walk a certain hour, maybe 22, then you will update the dog, update the dog for the dog company. As long as the number of dog is available for you within your maximum. So here there is only one company here, okay? And then there's a dog walk shift. Okay, we'll come to here later. Now let's look at the part A. Part A to write walk dog method which update and return the number of dog this dog walker walks during the time specified by hour. The hour vary from 0 to 23. A help function of the number of the available dogs have been provided by the dog walker class. So the method return the number of dogs available taken for a walk at a given hour, and the dog always walk as many dogs as the dog company have available to the dog that the dog walker can handle, represented by the number of maximum dogs. So if the number greater than the maximum dog, we will use the maximum dog. If the number less than the maximum dog, we will use the number of the dog available. And then a helper function called update dog provided by dog company that will update the number of dogs that have been walked for the given hour. So for example, that company had 10 dogs need to be walked at a given hour, but the worker maximum is 4, then update dog would be used to indicate the dog can walk 4 of the 10 dogs even for a given hour. As another example, the dog walking company has 3 dogs that need to be walked for a given hour, and the dog walker's maximum is 4, then update dog should be using to indicate the dog walker walk all the 3 dogs available. Okay, so this is not really that hard. So the method return the number of dog walked by this dog walker for the given hour. And you must use the number of available dog and update dog to receive the full score. Okay, not hard. Let's actually get started. So first thing that I would do is to copy, make it smaller. So let's copy here is a public integer walk dog, integer hour. Okay, then you are given the number of hours, and then you need to call the function that's called available number of available dogs. So this function call, you need to keep the hour that's actually you have. So you will call this one by the given hour. But this function is a instance function for the dog walking company. Number available dog walking dogs. So that one actually in the worker class, you have a company, so that's a primary variable. So you would do company, since this one is a instance variable, and you are worker, so you are dog worker, so you can see this primary variable, and then you actually check the if available dog. Okay, so you got a number. So if the number is greater equal to, let's see, actually the number is greater or equal to, let's see, your maximum dogs. Okay, so if your available dog is more than your maximum dog that you can handle, then you should handle all of the dogs. So in this case, you will do company update. Okay, it will do company update dogs using the hour and the number actually, and also the maximum dogs that you can walk, and you will return maximum dogs. That's a number that you can walk. Otherwise here you can use else, or if you don't use else, that's also okay. Okay, and then because everything right here already been returned, so anything left over here will be less than maximum dog. If it's less than maximum dog, then you would actually walk those dog, all the dogs. and you return the number of dogs you walk. Okay, this is part A. Let's look at the part B. Part B will be on a dog walk shift. Okay, you start hour and end hour. This is part B. Let's look at what is the part B problem. So part B problem, walk dog shift measure perform a dog walking shift of the hours in the range of start hour to the end hour. So it's a period of hour. Is inclusive and return the total amount earned for a dog walker. Say shift is 14 to 16, composed of 3 1-hour dog walk from these. For this hour, the base pay is $5 per dog walk plus bonus 3 if at least of the following. At least one of the following is true. Maximum dog walk, the walk occur at the peak hour of this inclusive. So it actually is talking about the salary that you, the pay that you actually get for the number of the dog you walk, and then also the whether it's a peak hour or not. Peak hour is 9 to 17. So let's see. Okay, let's assume that actually the following hour table is you walk from 7 to 10. 7 to 10, you actually maximum number of dog is 3. Number of dog walk is 3. Then each dog is $5 and plus a $3 bonus. If one of the following is true, it's maximum dog walk. It's a maximum dog walk, yes. The work hour is between 9 to 17 inclusive, that's true. And then second one is, okay, at least one of the following is true. So second one, the maximum number of dogs you can walk is actually 3. You walk 2 dogs. So 2 by 5, but it's also in the work hour of 8 is 7 and 17 between. So I don't know. Here I am assuming that we should also plus another 3. I'm not sure. I'll look at it later. That's 7 to 10, so 9. Okay. 10. Okay. And then I'm not sure why this 8. You don't need to actually plus the 3. Okay, this one seems you don't get the number of the dog that actually you want to have. So you must use the walk dog appropriately. So walk dog will give you the number of dogs that you walk. And then you need to consider the time from starting to the end. Okay, let's get started for this one. This one, I'm curious about this part, why this one, it actually is during 7 to 17, but the example do not have the plus 3 over there. I have a question on it because the work hour is between 9 and 17. Basically 8 is also in there. So I'm not sure why this one did not include it, because it's from 7 to 9 inclusive. I'm not sure why it's not there. Okay, anyway, let's get started for this one. I think this is a bug. Okay, this is a bug by the computer AP concept eligible. So this one, the problem is public integer dog worksheet. There's no S. So integer start hour and integer end hour. Okay, so you should have a amount of the total. And then at the end, you should return this total. That's actually not a problem. And then you need to have a for loop. So you do for integer I equals star hour. Then I less than equal to the n hour. I increase. Okay, during this different hour, first you need to calculate the pay. The pay would be based on the two conditions. Okay, let's see. Let's don't calculate pay. Let's calculate the dog W. Okay, that's the number of dog worked. So this one, because you are calling the instance function for the same class, so you actually call it a work dog. So you call this work dog for the hour that you have. So this actually should be work dog of the I. That's the number of the dog that you work. So if your dog W is equal to your maximum dog, you say that at least one of the condition is true, maximum dog. Okay, so actually, if you equals maximum dogs, or the hour I is actually greater or equal to 7. I'm sorry, greater or equal to 9. I'm sorry. This one, okay, it's between 9 and 17. So this is 7 and 8 don't have the maximum, don't have 9 in the hour. I'm sorry. So here I make a mistake. But anyway, it's okay. So that is greater or equal to 9 or I less than or equal to 17. In this case, you will have the number of the dog walked times $5 plus 3 bonus. Your total will be increased by this. Otherwise, your total will be increased by the number of dog walked times 5 without a bonus. Okay, this is the question 1, part B. So question 1, part A. Question part A, let's check it one more time. It actually you get an hour and you actually calculate the dog available as a num okay, and the available dog is a instance function. So if the number greater than the maximum dog you walk, you update the hour using the number maximum dog. Okay, if the number actually is less than maximum dog, you only update that many dog. And this is the dog shift. You have the whole shift total. So you actually get started with 0 and then starting now ending hour need to be included. And then if the dog equals the maximum dogs, or the hour is between 9 and 17, you number of dog walk times 5 plus 3, or the total actually increased by dog times 5. Okay, so this is question 1. Now let's look at the problem 2, the class design problem. So this question revolving the sign text class. So it's a class that contain methods that are used to include a signature as part of the string. You write the complete sign signature, write a class with one constructor and 2 methods, one constructor, 2 methods. So the constructor, you will get a first name and a last name. So if the first name is empty string, then there is a get signature, you will just return the last name. If the first name is not empty, you will use the first name dash last name. Okay, so this is a get signature. Another function called add signature. And the add signature will get a parameter that's called text. So this text will, if the text is not in the your signature, then you will actually just return. You will add the text plus the signature, and then return. And then if the signature is at the end, if the text is at the end of the signature, then you'll return the signature unchanged, the string unchanged. If the signature is at the end of the string, so signature is part of the string. Okay, signature is part of the string. And if the signature is at the beginning of the string, then you will remove that part and then put your signature to the end of the parameter. Okay, so this one is a class design based on the requirements. So let's assume that you have a empty first name and Wong, okay, and the get signature you will get Wong, okay, only the last name. If you have a Harry Dubious, then you will have the H hyphen Dubious, okay, only the first name, first character. If you have the Grace, then you have a G hyphen Lopez. Okay, so first name you only provide the so-called first letter. So string 4, if you have an empty string with Fox, then your last name will be Fox, signature will be Fox. And if you have a deer, then your Fox is not in the deer, then you provide deer Fox as a result. If your text is like this, your Fox is the signature is at the end, then you will return the string by itself. Then if your string is Fox sense, so your Fox is your signature happen to be to be in the beginning part of your text, then you actually remove that part and add it to the end of your signature. You remove that part and then have the remaining part and then put it on at the end of the signature. So right here, you have the beginning part as a 0 base. So you will use the hello and then put your signature at the end of your word. Okay, so I think it's pretty straightforward. Let's get started. So it's question 2. Let's call it sign the text. Okay, since it's the class, this class name is called sign signature. And they have no inheritance or any other things that involved with it. So let's call it a public class sign text. Okay, now you should have a string of your first signature or string of your last name. Okay. And then you have a constructor of sign text. Okay, you get the two string. So if the first one that equals, I'm sorry, your input first that equals empty string. Then your last URLA. I'm sorry, this constructor actually doesn't matter. You can assign your first equals first, and then your last equal LA. Now, next one is the function of the get signature. So get signature will return a string so here, if your first that equals empty string, then you should return your last. Else you return, okay, your first that character at 0 plus a hyphen plus the last. Okay, so this is your get signature. Next one is your X signature. So your X signature's return will also be a string. For this one, you will get a text. Okay, so here actually you will have a string S equal get signature. you get a signature, I'm sorry. So if s that index of, I'm sorry, the text but not including the signature, you do something, okay? So if it is not included in there, then in this case, what will happen is that you will put your text before the signature. So you should return the text before your signatures. Okay, this one's actual. So if your text index, I'm sorry, actually text substring of the signature text length minus, okay. So right here, let's calculate two things. Let's actually calculate the integer text width, integer signature width. Okay, so here you subtract from your text width, text length minus SW. Okay, this one is you have a text, your last SW word, okay, that equals your signature. So your signature happen at the end of your function. Okay. Then in this case, you will return your text unchanged. Let's see. This one, let's see. Actually, this one happens when you pass which box, and your box is at the end of your text. Then your signature as signature parameter. So the return string is unchanged, the value of the parameter. So the parameter will not be changed. So here, let's see. Okay, next one is that if the signature occur at the beginning of a string, so here if text that starts with the signature. You can use that, or you can use the substring of the 0 to the SW length that equals S. That's also okay. Then you take out your signature from the beginning. So you actually starting from your SW, then you will return the X plus your signature S. Then there's a one condition that not being covered, that if, okay, I'm sorry. These two seem to be need to be happening first. Okay, so you put them beginning. But they do not talk about the case. There is another case that if your signature not be at the beginning, not at the end, what happened? Let's look at this one more. So if the object signature does not occur, the string occur in the text string, returning the parameter to the end. That's one case. And then at the beginning and at the end, but there is a case that if it can occur in the text, but not the beginning, and but also not in the end, what will happen? It doesn't say. So this one, you can check these, or you may just return it. Just return it means like it happened in the middle, but it's not the beginning, not the end. You will return this. But this one right here is a little bit ambiguous for this FRQ problem. That happened to be if your signature happened in the middle of the text, but not the beginning or not the end. And the beginning and the end are handled. And actual case, you return, or you can do this. You can do this, and you actually do return X plus S. Okay. This one you can return empty string, but there's no tail that it actually should return string, empty string, or should return this. But to be safe, because we don't want to violate the requirement by the AP College Board, so you return the empty string is probably more dangerous. So I suggest that this one actually not covered in the problem statement, assuming A plus S should be returned. Okay, so this one a little bit ambiguity here. We'll move on to question 3. Now we'll be working on the problem 3. So the problem 3 is actually a competitor problem for the tournament. It will actually put those competitors into one-on-one match. For this one can be a badminton or a tennis or a table tennis competition, those kind of single elimination games. So each competitor has a name and the rank, string and the integer. So there is a constructor like that. And then there's a match. Each match has 2 competitors. Okay, so match. And then there's a run, single run. Okay. Now, basically, you need to write the run constructor and also a function called BO match. So for the run, so for the question 1, question 3, part A, to write a constructor for the run function, run class, the constructor should initialize the competitor to contain one competitor object for each name of the string. And then the competitor should appear in the competitor list should be the same order as appear in the name, and the rank of each competitor is based on the name's position in the list. Okay. So it is in the best rank number 1 to the worst rank. Okay. So this one actually is to create from loading an array to a loading an array to an array list problem. Okay, so let's look at this one called Q3A. Okay. So right here, this one is a constructor, so we would have a run. And this run will be taking in a string of the names. Okay, that's the constructor's signature. Then there is a competitor, but this competitor list is not initialized. So we need to do initialization for it. So it's a competitor list equals new array list of actually competitor. Okay, constructed like that. You need to build that first because initially you do not have a array list of competitor, so you need to build it first. Then you go through every name. So for integer I equals 0, I that's then the names at length I increase. So you are going to create a competitor C equals new competitor using the names I and the I plus 1 as the rank. Put into the array so that is your initial rank and the string that you create a competitor. And then after you create a competitor, your competitor list will add your competitor into there. And then you should be able to load every name into the competitor list. That actually is fine. Next one, we are going to work on the Q3 RP. So part B, you are going to create matches. You are going to work on the build matches function. So public array list of a match, build matches. Okay, you build the matches based on your competitor list. So there are two cases. So if your competitors list size 10 modular by 2 equals 1, this one is the up case. So here you create an array list of match. So right here, let's look at the array list of match. The competitor contain at least one element. Okay, so okay, so right here you create matches M equals new array list of match. Okay, if it is odd number, what will we do? We actually will pair them. We'll pair them and put into the array list. So there's an odd number and then there's an even number case. So let's assume it's an even number case. Let's actually work on it first. So at the end, you will return your M. So there's an odd number case and even number case. So now let's assume it's an even number case. Then what you would do is you will match up so you match your best with your worst if it's even number case. If the odd number case, you will match up, you will ignore the best one and then match up the rest. Okay, let's assume that we are on the even number case. So you have 1, 2, 3, 4, index 0, 1, 2, 3. Then you will match up 1 and 4, 2 and 3. So let's assume this is even number, you have a n. So n divided by 2 is right here. So you actually should do for integer I equals 0, I less than competitor size. Let's actually do this. Let's actually do integer SW equals CW, competitor width equals competitor size. So this one, let's change it to CW 10 modular by 2. And this one, actually, let's do CW divided by 2 and I increase. So you have an I get started from 0. So let's actually do competitor C1 equal to competitor list that get I competitor C2 equals competitor list that get CW minus 1 minus I, your symmetrical location. So your 0 would match up your index 3. And then queen would be 1 to 4. But this one's 0 to 3, that actually is fine. And then you actually create a match based on these two members. So match x equals new match using the competitor 1 and the competitor 2. And then you actually your n at your match x. Okay, let's assume it's an arc case. Arc case you have 0, 1, 2, ranking 1, 2, 3. Your total length is 3. Your n divided by 2 is this one. So right here, you should do this. You should do okay. Let's assume that you have 0, 1, 2, 3, 4. So you end up to here. This one is n divided by 2. So you use this one from 1 to n divided by CW divided by 2. That's actually 1. So right here, you do the similar things. You create competitor 1 and competitor 2. So competitor 1 is your I. And then your I right now, let's assume is actually 1. Your symmetrical location is right here. It actually is 3 minus 1 minus 0. So here, this one should be 3 minus I. So let's assume here you have index of 1. It would be 2. If it is 2, it will be essentially I is 2, 2 or versus actually you would have this one, it would be 4. So this one it should be, this one is 1, this one is 4 minus 1, 0, 1, 2, 4 minus this one is 1. This one is should be this is 5. 5 minus 1. 5 competitor. So if you are index 2, you have 5 minus 2. So this one is CW minus I will be your index. And then the create match and M match to the match list is the same. Okay, this is problem 3. Now we are going to work on the problem 4. Problem 4 is a question regarding a puzzle. Okay, it's a 2-dimensional array problem of the integer, and then the array, the metric will have value between 1 to 9. So these are the random number 1 to 9 that you need to generate. So you will need to work on the part A. Part A is the sum or same game. You will create number of row, number of columns. So you have the row number, column number, and then each one is a number of 1 to 9. So let's work on this part A first. It's pretty straightforward and easy. So this problem, let's see, this problem is called puzzle. But the class name is called, let's see. The class name is named as sum or same game. Okay, let's use this one. So that's actually, okay. And then let's look at the part A. I'm sorry, let's look at the part A. So part A would be, okay, the constructor for the sum or same game. So let's get started. This one is called it sum or same game. This one is Q4 public class. Let me switch the language to Java. It's called sum or same game. Okay, I'm sorry. This one actually is a function. It comes with the integer, two integers. The two integers are number of rows and number of columns. Okay, first, this one is it actually create it's a two-dimensional array that's called integer puzzles. So these puzzles. Or you have so many row and column, and then you get started to initialize each one. Then you do follow for the column as well. Okay, right here you have a puzzle of your row and column. Now with new integer. Okay, here actually it is an integer, so you would like to do master random times 9. This one will create a number from 0 to 9, but not including 9. Totally 9 samples, so you need to do quantifier. So 9 numbers, and then your base is 1. Then you would here you create 0, 1, 2, 3, 4, 5, 6, up to 8. And then plus 1 will be 1, 2, 9. So that's it. This is okay. So this one finished the part A. Now let's look at part B. So for the part B part, there's a function called clear pair, and you get the row and the column. And you based on those row and column, if the row and column say you have 0, 1, as a 7, and you go through it, you do see a 7 over here. Your 0, 1 is right here. Match the value, then you will clear both. So right here, if you have the 2, 2, 2, 2 is actually 1. So there is no row of a later row that actually pair with one later row. There's no one later row, so you actually do return false. So next one, you have a value of the 4 in the 1, 1. In 1, 1, you have a 4. And then you have the value of the 6, 1 in 1, 3. 6 in 1, 3, and you have a 4 that actually is in 2, 1. This one is the pair. This one is actually match. This one is actually same. This one is actually the sum equals 10 rules. Then you clear the one that match it first. Okay, so what you want to do is that you will start from your row and column number, any number that actually behind you, to find the clear pair. So it actually is to take the valid row and column index as its parameter. The array specify the index, okay, from 1 to 9 to have a value 1 to 9 is compared to the array puzzle in the 10 to it. So the row index of the second is greater than or equal to the row number. So it's the same row or bigger that you have the same number but not the same one. And then 2 elements have the same value or equal to 10. Okay. So same row or the after rows. Let's make sure. So next one you have 0, 2, you have a 9. And then you do have a 1 in 0, 0. So this one also is a match. So clear both. So that's pretty clear that what we want to do is starting from the row to the end of the value to do clear pair. And you return true or false for it. And that's not hard. That's actually do it. So let's copy the method signature. The method signature is right here. Let's scroll it up a little bit. Okay, so public boolean clear pair. Okay, so what you want to do is that you need to create a row and column. So for integer row equals row, row less than puzzle length, and then row equals for the integer column equals 0, column less than puzzle row balance, and then column equals. Right here, you need to make sure that the row not equals column. No. The row not equals row. Or column not equals column. Okay. Then you should actually get integer x should be equal to puzzle your row and column if x plus puzzle row and the column equals 10 or x equals puzzle then what you would do is like puzzles row and the column equals, you clear it, and puzzles row and the column equals 0, clear it. Then you will return true. If you cannot find any one of these, then you will return false. That's it for this question 4. Thank you. Bye now.